Hi everyone, my name is Andra, and in the following slides, I want to present a project collecting data via Ethernet into database. So, what is the project based on? The following project is based on an LDR sensor which collects the data and store the values of the light in a database. For this project, a database in SQL language and PHP was created. The database has two columns. One has the header sensor ID, and the other column has the name sensor value, where we can see the stored values. Okay? The values from the LDR sensor are stored in the database. System is actualized by every 5 seconds. Table will be displayed via HTML language as a web page through the local host. So about Arduino Uno, everyone knows a little bit about Arduino Uno. It is a microcontroller board that is based on the Atmega 328. Arduino Uno is composed of hardware and software, so the physical hardware that we use and software with the Arduino IDE. The Ethernet Shield is an expansion board for Arduino, like microcontrollers. These expansion boards are generally referred to as shields and are simply plugged onto the corresponding controller or single board computer. This simplifies the connection of special components enormously, like sensor boards where we can connect many sensors. This special design adds an Ethernet connection to an Arduino. This allows the microcontroller to be integrated into a LAN network and thus also stream sensor data to the internet. For example, this module is also the cornerstone for any Internet of Things project. Yeah, so in the most Internet of Things, we will use an Ethernet shield, or for instance, in a smartwatch, we can use a Wi-Fi shield because it's more suitable. Yeah, we have to go everywhere with that smartwatch, so we can connect with with an Ethernet cable. The LDR. LDR is a photoresistor. A photoresistor is a semiconductor whose resistance value is dependent on the light. It is also called LDR, a light dependent resistor. Yeah, what we speak about this LDR. And this here is also a picture with the LDR that I have used in this project, where you can find it on Amazon, on different websites. These materials, what I have used in this project, because it is a physical project, I didn't done a simulation, so I have used the Arduino Uno board, the LDR sensor, an Ethernet shield, and an Ethernet cable, and of course the little wires to connect to the pins from the Arduino and the LDR sensor. And now going further to the Arduino code. First, I have initialized the Arduino code with include spi.h library and with include ethernet.h library. This SPI library, Serial Peripheral Interface, SPI, is a synchronous serial data protocol used by microcontrollers for communicating with one or more peripheral devices quickly over short distances. The SPI library is included in every Arduino code or platform, so you don't need to install it externally. And the Ethernet library enables network connection, local and internet, using the Arduino Ethernet board, so the Ethernet shield. This library was used in the first part, yeah, of the program. So at the start of the program, we'll see. After then, the MAC addresses need to be initialized. So the MAC addresses I initialize like this, and this need to be unique on the network. So with Arduino compatible boards, you usually need to configure their MAC address in the sketch. So most of the times the MAC address is written on the board, but for kind of projects, we can use the standard MAC. It will work for sure. And the IP address, here is by IP address, IP with written with comma, the numbers. I have declared my Arduino Uno IP address, and in the code, I have also declared the IP address of my computer. So the IP address of my computer are these three numbers and also another one at the end that makes a difference for the Arduino. And so I have searched for an available one, and I have chosen one for my Arduino. You will see. With serial begin, I started the serial communication. And in this part of the code, I have initialized the Ethernet library and network settings, yeah, with ethernet.begin, the MAC address. We'll see if I receive a DHCP address, and here we'll start the Ethernet begin with the MAC and the IP address. So with version 1.0, the library supports DHCP. Using Ethernet.begin MAC with the proper network setup, the Ethernet shield will automatically obtain an IP address. This increases the sketch size significantly. So further with client.connect with this function server, comma 80, function will connect to the IP address and port specified in the constructor. So in my project, the server is the IP address of the computer, and the 80 port is the used port in SAMP. Yeah, so to create our local host, we need this SAMP app. I will show you. Client.print, yeah, with client.print, we have used this function to collect the data and writing into the current folder. Yeah, so to write this data in our database. For the local host connection, I have used SAMP control panel, as I said, and in PHP my admin, I have created the database via PHP code. I have two files, one for writing the data into the database and one for getting the data in the web page, so HTML. The table for PHP was created with the following code. Okay, so create table. I have here my table, so you can write also table is test or table is sensor or photocell or what do you want. And I have my table with sensor ID, underscore ID, and sensor underscore value. So you can write it as you want. You can write it only ID or only value or what do you want. So for writing the data, it was used SQL is equal to insert into table in our table sensor underscore value. Yeah, so the sensor underscore value. Yeah, so this is not how I called at least, but it's okay. Sensor underscore value. And the sensor, where sensor is the value obtained from the get function. Okay, so what here we obtain, and so we will get the value that we will receive from our LDR sensor from Arduino. So this is connected together with this function get. For getting the data, HTML code was used. Title, for instance, was set for the following function. So we have the title is light sensor, and the rows are row with values from the sensor underscore ID and with the value from the sensor underscore value. Um, so, and for connecting to the URL, I have used the following function to request the URL. And with the header refresh 5 URL, this one will refresh the page from 5 to 5 seconds so that we receive precisely values from time to time. You can add 30 seconds or more or less, or how do you want. So this was the first part, the slides. And now I want to present further. Here is a short video about the connection, about what we have here. Here's the LDR sensor, the wires. After then, here's the Ethernet board. And we can see here we have connecting on the A0 pin. This is our Ethernet cable. And under is the Arduino board. So the Ethernet shield is connecting into the Arduino board. Yeah, so here down is the Arduino board and upper is the Ethernet shield. This is our Ethernet cable, which is connected to the Ethernet board, and the um, second part of it is connected into my router. Yeah, to be sure. And here is and this black wire is connected to the Arduino Uno board and to my PC, or yeah, we can power it also via power supply. Yeah, and then we have the connection to the A0 pin, to the ground, and to the VCC from the LDR. And that's it regarding the connection. Okay, so going further, we have, as I said to you, this is the XAMPP, and I have connected it. You can see the Apache is connected on port 80. So this is what I took. Okay, let me show you also the database. So here is the table underscore sensor. Yeah, here I have many more um, projects where I tried to do this. So, but this was the last one. Okay. And here we can see our get data, our HTML web page, which I displayed on the local host. You can see the connection with the local host is done via this example. Okay. So this is what I used. And these are my two folders, the get data and the folder with the write data. Okay, so write data. As I said, I have used here the photocell reading, which I have in the slides. I think it was sensor, but it's the same. It's just a variable. You can put any name you want. Okay, and then with this value, I have called it here to put my data into the database from the LDR sensor from the Arduino. And in the get data is what I have displayed. Yeah, here I have created a connection. I have created, and then from my table I have the table underscore TBL underscore sensor, which is ordered by from the greatest one to the lowest one because we have to see the exact values first. Okay, and then we will see here from this row the sensor ID and the sensor value will be set in our table under the ID. This is from our table, the table border, okay, and the values. Yeah, so the value, what I said, and this will take from our SQL database, so from here. Okay, let's see how this is working. Let me connect my Arduino board to my PC, but no, first I want to show you here the Arduino code. Was to forget. Okay, so this is what I said, the initializing the MAC address, the IP address from my Arduino. I initialized the LDR sensor to the 0 pin and then to this float because sometimes, yeah, we can have also float values. Okay, I initialize the server. The server is the IP address of my computer and the Ethernet client. Then in the setup, initializing the serial communication and Ethernet communication and going further to the void loop. So what should be repeated is the photocell, we read the analog value of the photocell pin. So from the LDR sensor that we have, and with the client connect that we have discussed, the server, so the IP address of my computer and the 80 from the XAMPP, it is connecting. He will get the data from, yeah, this is not so mandatory. Yeah, this is mandatory client print. Okay, so to get the data from our current folder. So from this file, the right data. Yeah, from here it will get the data. This is how they communicate. Yeah, via this get function. Yeah, this how they communicate. Okay, and then only print and this client print, this is the standard from the IP communication and the host, this is also my computer host. Okay, and if the connection is failed, then it will inform us that the connection is failed, else it will print. Okay, so let's see here. I will connect now my Arduino Uno board. Okay, it is connected. Okay, the code is uploaded. Okay, and you can see, okay, we have here different values, and it starts and updates from with updates from 5 to 5 seconds. It will come with an update, as you can see. Okay, let me change a little bit the light from my room. Okay, so you see it changed. It is changing. Okay, so we have another values. Okay. And you can see also the values, if you give here a refresh, it will also appear in our database because it connects the data from the database. Okay, so this was my project. Thank you very much, and hope it will inspire you. And of course, we can do this with a temperature sensor, with a humidity sensor, or what comes to your mind. It is very interesting, and I think this is very used in a production because there we need exact values. Yeah, so from time to time, from maybe from 10 to 10 minutes or something like this. So what we have to create is very simple, and I enjoyed the work with the PHP My Admin because it's easier to create the SQL and the PHP in a notepad for instance, and not in the SQL workbench. Or how do you think it's easier for you? You can create it for sure. Thank you very much. This was